Here we're going to walk through running an Anova test, which is what you're going to use if there's a multiple category explanatory variable and a quantitative or ordinal response variable. And the multiple groups being compared are independent. In other words, you don't have paired data. In order to do this, this data set, we have a host bird. We have, I think, 4 different kind of birds, and they're different egg lengths. So what we do is we go up to Analyze, Compare Means, One-Way ANOVA. When you do this, the One-Way ANOVA box pops up, and we will put egg length into our dependent list or our response variable, and host bird will be our factor or explanatory variable. Once we have that selected, we go over to post hoc, and we will use a 2-key post hoc test, and we hit continue. And we also want to go probably into our options box and get descriptives, which that will give us our standard deviation and means. And we hit continue there as well, and OK. And up pops our output window. And we will wait till that comes up. Okay, there we have that. So if we scroll down a little bit, here we'll first take a look at our descriptives box. So it gives us our mean egg length and the number of eggs for each kind of bird, standard deviation within each group, 95% confidence interval, all that stuff. And notice that our standard deviation between our largest and our greatest, they're within a factor of 2, so that's good. And now we look at our ANOVA box, and we see a significance between the groups. The significance is 0.000 or less than 0.001. So that tells us that we have evidence that at least one of the group means is different from the others. And since we had a standard deviation that was within a factor of 2, we can run the 2-key post hoc test, and that will be more specific and tell us the difference between groups. So here is that 2-key post hoc test, and here's the difference in means, and all the starred ones are significant. So notice that this entire box right here is starred and significant to the less than 0.0001 mark. So that tells us that we have evidence that the wren has significantly different egg lengths than all the other kind of birds. And notice also the confidence intervals, that they don't contain 0, and that tells us that that's significant as well. And finally, we have a table called homogeneous subsets, and this tells us basically that since the wren is in a different column than the rest of these birds, that average egg length is significantly different than these other egg lengths.